So welcome everyone for Cloud Computing and Big Data, our practical lecture 5.1, the second part of understanding MapReduce in cloud applications. In the first part of the course, we really reviewed a little bit the concepts of MapReduce again. We learned that it's basically inheriting concepts from divide and conquer. So really traditional elements where you basically crush a big problem into very smaller ones, and then with a reduce, so to speak, you combine all of these results back to, let's say, the solution. And there's a very smart framework which is actually doing different steps, not only MapReduce, but does also sorting, shuffling, and grouping in between for us. And here is, of course, where one of the benefits of this is. And one of the implementation of such a framework is the Hadoop, or basically Apache Hadoop. While I think the majority probably are aware of the Apache Foundation, which has lots of open source projects, and which is, of course, then also another key element in this, that the MapReduce is just the basic framework, the really computational paradigm. And on top of it, you can put NoSQL stores, which are then very easy to be connected, let's say, from HBase to Apache Hadoop to compute very quickly on the data that you have in another Apache project, so to speak, in terms of software. And it connects to Mahout, which was machine learning, where, for instance, there's another logistic regression implementation to use. We don't need necessarily always Apache Spark MLlib for logistic regression. So these are all, let's say, interesting open source frameworks, which in one way is very nice because they're open source and we can install them maybe also on our own premises. And with this, we basically have lots of work to combine all the different versions that you have in these different platforms. This is open source communities which have everyday commits, which are really lively sometimes. Some of them are actually dying out. So it's a very lively community. So to keep track of all the different versions that should be in harmony together, deployed on a cluster, can be very, very cumbersome. Hence, the move to cloud applications in that particular area really makes sense to think about. And again, what I was alluding to in the first lecture was almost all commercial vendors have it in, of course, the enterprise editions. Unfortunately, we learned that in the education sector, MapReduce is more and more phased out, maybe because of the significant costs of having workers and then masters and so on, but we can only guess that. But basically, we see that AWS, the web services, have it as Elastic MapReduce. We have Azure with HD Insight offering MapReduce, Hadoop, and the whole open source stack of Apache. And of course, Google Cloud Platform, which we will also explore later in this course, will have the so-called data proc service with all the analytics stacks as well. And you can go on and go on. Alibaba Cloud would be the next one to refer to as a MapReduce implementation existing and so on. So let us look a little bit now with a look and feel, however, how it works in Amazon. And the thing we did before was also we created some key pair, which is always required if we want to go to Amazon and looking there and in creating resources. And of course, looking also that they are related to cost factors. So when we go back to our last lecture, in lecture 5, from the theoretical point of view, we have reviewed MapReduce a long time. And one of the key, let's say, hello world applications in this community is really this WordCount application, where this is just very beautiful, very slim to implement. Because essentially, as I said, what we only have to provide as developer, so to speak, is the map and the reduce task. So all of that sorting, shuffling is based on specific keys. And when we have basically these keys well defined, it will solve our problem very nicely. And there are lots of different applications, even in biology, in different sciences, which take care basically of a very nice key value pair idea. And with this being really able to extract lots of, let's say, added value from these frameworks. So when we have just one key in a very, let's say, trivial fashion here as a word count, where we said, okay, a key could be something like essentially the word itself. And then basically we want to have essentially the values and always iterate on this. So every time I have the occurrence of the word, I would just add another one. Hence, when what I get out here is, of course, when I give some certain string value in, basically then all I wanted to have is essentially then I would do a lot of W's here, or the word, and would just have a 1, so the occurrence is there. With this, you count the words, but of course you would have, of course, always the same words, always 1, right? So you have many different of those, and you want to combine this and want to do some addition on this. And you see that the map task is stupid in this sense and doesn't do it to be simple, right? With this being so simple, it's of course dramatically quick to just make always a 1. And that is one of the key ideas when you use this in this particular application. So still, when you then have essentially this as the output here, you see the word key and the 1 which goes into the reduce. Of course, here, the idea is now that the framework sorts and shuffles all over the cluster, which is very distributed, like here on the top. All of those it will collect that have the same keys and sorting them and shuffling them. And being done so, they will be given to the reduce. And now the reduce is basically nothing else than just iterate over these values and actually now counting. So in a way, you get then a beautiful list out where you have then all essentially this numbered counted listed. And the idea of how many lines of code you really have to do for this, it's, let's say, very remarkable. It's almost nothing. And then also think about this scales now to 100 terabytes, to 200 terabytes, to maybe a petabyte of string data, right? So it's all distributed maybe on different databases, and the whole framework around it takes care of the complexity of big data here. So it will have the data replication strategy, will have several different nodes here. The data may be replicated. It will basically take care of the map task to be there where the data is. The reduce task can be maybe somewhere else because we have already as an input to the reduce task the key list, right? So we maybe don't need anymore the original string values. So this is something which now could be put to a Twitter text stream, continuously updating 24/7 on the cloud environment. So it's a very powerful framework, and lots of different MapReduce implementation exists. And if you have seen, let's say, Mahout, for instance, as a machine learning framework on top of all this stack, what they define then within their specific implementation on top of Hadoop is then also just essentially map and reduce tasks. Of course, there's a bit more in terms of logic than more complicated algorithms for machine learning. They are the optimizers and so on as well. But still, the key idea then how they will ship it out to essentially the cluster will be then done by map and reduce tasks. But this is something what we will see in one of the later lectures, actually here in the course when we come back to machine learning. So let us now look a little bit how that looks like when we now want to use the cloud again as a practical lecture. This is the usual recipe, the 7 steps we had already from the beginning. And of course, think about that. We always think about, we just want to do this when we have really big data, right? So if you have very tiny data sets in the order of megabytes, then you're probably better with Jupyter, Anaconda, scikit-learn, and some local laptop business. But we will also see already next week when we do deep learning, a laptop is actually almost unfeasible today. Only if it's equipped with a GPU, it would just work. But having then clusters already plays a big role and is a big difference. However, this could be different ideas. We have this low load runtime, so less GPUs. We cannot scale on a laptop. And also, of course, when you have big data sets, if you have, let's say, this 100 terabytes we discussed, of course, you cannot just simply put that into, your memory somehow. And these are the steps you basically, in a way or another, always have to modify a little bit, but always follow the same pattern. You always check your subscription. Here in our case today, we have a pay-per-use, so I swipe my credit card to get the access. We will do a Spark cluster in AWS Elastic MapReduce. It also has a MapReduce implementation inside. Here you could also basically, as we will see later, then have the Hadoop and so on indirectly used. Then you would start up a Jupyter notebook, which then uses maybe the SpyPark kernel exactly the same way, in a way, how we use it in MS Azure. So you see the look and feel is almost similar. A bit special is here that we have an AWS S3 service, which is essentially storage, so-called bucket storage. I come to that basically as part of the second half here in the course, where you then can have some locations for data sets, inputs and outputs. If you remember, that's the same one that also Spotify was using. So when you then deploy the cluster, you remember we can now do different things. We can say one master, maybe 20 workers, maybe 2 workers. And this, of course, depends on how big your problem is. Do you want to digest 1 gigabyte or 200 terabytes? So here you would adjust accordingly. So this deployment of an Apache Spark cluster with Hadoop and Elastic MapReduce is, of course, very flexible, as we will see in the demo. And then you can perform an automated word count very easy on the cluster. It's a predefined installation already. It's a predefined application, really, that we can use. And of course, at the end, what I say always to you, once you have done the analysis, think about terminating the cluster, right? If you don't terminate the cluster, the prices and basically the cost of the cluster will continue to take money away from your credit card. Of course, not on a daily basis with a direct bill, but it will accumulate, and every month you get a big bill suddenly that your cluster was running in the background, although you don't really use it, but you already had an instant of basically this cluster used. So make sure to terminate the cluster. Now, when we look at the subscription, here we were, let's say, not so really happy this year. Last year, we were very happy that we got the AWS Educate resources for free. We don't do this anymore. And from my previous 8 years experience teaching that, of course, no student really is very happy of giving the credit card, right? If you want to do it, then of course, go ahead, it works. You can use the Elastic MapReduce, but be careful, right? As I said, with the costs, it can quickly accumulate, and I don't want to be responsible that you pay hundreds of euros just for basically using the Amazon EMR program once. So if you use it, be very careful, think about terminating the cluster directly after you try it. And as such, we cannot do it here as the assignment, as I told you. Also, when you look at the so-called AWS free tier, which is also a very good idea, essentially, of AWS to provide, let's say, additional services, you see, we can already use the EC2 services, for instance, for free. We can use some storage for free and lots of other different services. If you would scroll down here, you see lots of these services initially are free for a certain amount of time. You see 12-month free, 12-month free, and suddenly then after that you want to pay. Of course, this is a hook mechanism, right? So once you have started to use these services, you implemented your services, and then you want to merge to another cloud vendor, it might be not so simple. So you maybe just better stay on Amazon, and with this, they have fulfilled their goal of hooking you up to this platform, which is a big debate, of course, these days, that the transformation, or basically would also say migration of applications from A to B in clouds is not so easily simple possible, really, because you have essentially still notebooks maybe on different sites. So you could say machine learning code can be transferred, but as soon as you start basically combining those services, you will see here we use Amazon S3 in combination, of course, then with our Elastic MapReduce. So already 2 services are used, the storage and the computing. And when you now move the computing away to another cloud, the question is how easily you can access or create another storage. And as we also discussed, these frameworks are incredibly useful when it's about data accumulation. So when you basically increment your data over years, so once you maybe have accumulated 200 terabytes, it's also not that easy to just, let's say, copy them on an afternoon to another cloud, because migrating 200 terabytes from one cloud to another takes hell a lot of time. So these are all challenges. And of course, the idea is why these subscriptions, and you would have several similar things in Google Cloud platforms. There's free resources. There's MS Azure gives you free resources. Not all the services are free, as we basically painfully realize now with the MapReduce, but there are lots of different services where you can already, let's say, look in. One interesting one in AWS, which we look in later, is a SageMaker. It's for machine learning, again, a software as a service platform, but this is something where we need, let's say, more meat of the course before. So let us look how that would work in practice when we look now a bit more in the cloud again. We have looked at all the different instances. Now, that's not what we're interested in. You know, also smartly, they don't provide the price here, right? When you pick it, the price has to be taken from a website because it always keeps changing, but it gives you already an indicator that, you know, here very quickly you can pick very nice things with lots of different memory, but in the end you pay hell a lot. And this is, of course, something, a word of warning again. But if we go back to the console, which is essentially a central space where you always come back to, you will basically see now the option of EMR, which is our Elastic MapReduce framework. And you also see already, I have already created 2 here of those. So let's create just another one here in this part of the lecture. And you have here different options, and the majority of the options that you see now is actually all on the cloud, on the slides. So of course I cannot do every single option show to you, but essentially the key meanings you will basically see. Now, when we look through all these different releases and so on, you will always notice that there are different configurations of software that you may want to install. So for our purposes, we want to have Jupyter notebooks. We learned Jupyter Hub is the right environment for it. We know that Jupyter Enterprise Gateways here in clouds is a very specific framework really to connect the cloud then to this. Sometimes there's some errors with this, I have to say, but this is just what we live with. But this is also required essentially to connect the Jupyter then to this framework that we have here in the AWS area. We have HBase as a NoSQL store as an example. We have PIC for scripts, we have Hue, and of course what we also want to do a little bit was the Spark 2.4.7. You see deep learning frameworks like TensorFlow would be another option we could do, but we do this next week. So then basically you know already would be the same modus operandi. Mahout is basically available here. As I said to you earlier, that is a machine learning framework on top of Hadoop, which essentially is here. But here already see that different versions matter. MXNet is another deep learning framework, but all these different services really matter in different versions to work together. Hence, you see this particular drop-down menu with hell a lot of options. And these come basically because the configuration assistants at AWS make sure that these configurations you can put in the releases are somewhat harmonized with all the different versions, which is of course very important for us. Now, let's create a cluster because it will take some time, so I have to do and get going. It's around 10 minutes even actually, where some clusters would take time. The storage mode would be HDFS. As an example, we said it's a new SQL store here, HBS storage. And then we can essentially go to the next step. So this is just a software configuration, essentially what you want to do. Then in the next step, you can actually now configure, as it is said, the hardware underneath, which is again our EC2 resources, right? No surprise there. Of course, we're reusing here now the EC2, and with this another service of the cloud. So essentially, by combining all of this, we would say we use the EC2 in terms of pure hardware. We use the EMR on top of it, this Elastic MapReduce, in many different software configurations, and we combine it with an S3 service, which has all the data. And you basically see here the core amount, the gigabytes. We don't have very strong, cores here to keep the cost, let's say, to a specific degree. You have the master and slave, or basically the master and worker paradigm. This can be fine-tuned with a more task level parallelism, what we don't really do here in the course, but it's a fine-tuning option. But now, of course, you can think we have one of this master that really organizes all the different workers. And here, of course, now we can play and to create, for instance, 30 workers that really do the work, or just 2, depending on how much data you really want to process. There's also some other options like cluster scaling. So automatically you could actually do a up and down scaling. This is also something nice, particularly in Amazon. That's where basically the name Elastic comes from, right? Elastic Compute Cloud. Elastic in terms of scaling up, scaling down the requirement of more computing or less computing, or Elastic MapReduce. So depending on how much data we have, we can elastically, so to speak, do the management scaling down and up. But this requires to do more scaling policies, more details to really look in. And you see also nicely here in the auto termination, really, that there's an option that essentially, depending on your policy or a maximum of 24 hours unused, you auto terminate it directly, right? As I said, if you have a very memory intensive CPU with $28 per hour already running since 24 hours and you don't use it, you already have some accumulated euros. But if you don't stop it, it will continue the next day and the next and the next. And then the end of the month, your credit card will be billed. And then suddenly you have had a lot of money. So enable auto termination is sometimes also very good. And this is an elastic block storage. This is admittedly basically something we will allude to in another, let's say, lecture later. Would be too much material to put all in one lecture. But here we have, let's say, configured now the real hardware. First the software, now the hardware. Now we basically want to have some cluster settings, some trivial stuff like the name, where we say this is a CCBD 2021 cluster, and we have already a couple of names. So in order to keep track, it's good to rename them properly. And you see already, I just here as demo purposes have already a couple of clusters. So think about when you do this in production, then you end up with many different ones. And when you pick, of course, a name that's already taken, then it is basically an error that cannot be used anymore. So here we just have the cluster name. We say the logging should be in a specific S3 folder to understand if there are problems occur. Let's go to the next here. And now here comes the interesting part, what I said earlier, right? So now we have done the software, the hardware, the cluster setting, but now the security. If you want to have this Hadoop interface and we want to maybe access it with SSH keys later on, then it's something where we need our key pairs again. And you see here, you have to select those that you already created. And here, of course, no surprise, we take the one that we created together in this step to connect now your key pair in this particular zone, basically to this particular cluster. And with this, your private key will be able to match the public key on this particular cluster. And then you can actually access it and use it to actually get to an SSH connection to it. This is something more for the infrastructure as a service. It's really plain metal, so to speak. And here are some policies. I think this is something in the moment not so important, but it's about more, of course, security options. You can make it really secure in different zones and roles and so on. But for now, we keep it simple and stupid. So let's create the cluster because that will take a while. So of course, now what the system is doing is essentially deploy some EC2 instances with virtualization. Inherent will be this kind of predefined setup with the applications that we set from the open source stack, right? So this will include Hadoop, will include HBase, all these different applications we essentially have used. It's a specific Hadoop distribution here that is then basically deployed depending on our EMR 5331 release label. Of course, the different ones. Also, Spark comes with a new version. So there's Spark 3 around, which you can use as a beta version. So there are lots of different elements where, of course, this now all depends. So in other words, it has to be created first. So here now the cluster is starting up and provisioning, as we call that. It's a step where the master and the cores, so the worker nodes, are essentially on this type of CPUs you see here, deployed, a step we call resource provisioning. In other words, the software is installed that is basically then, of course, complementing the master in Spark, the workers in Spark, but then also all the other software that we have seen here. So in a way, this takes some while. And before you not have done this and finished this, it's always, not possible to really use the notebooks and so on. You see, essentially here, several elements that the different notebooks that we're going to create always have to have a cluster that really works. And while these two that I created earlier to test everything essentially are already green and are deployed, we see here is a problem, or basically we're just waiting. Here it's starting up, and essentially the request is basically here even failed in one request because we have the quota over. So in other words, I have to delete other clusters first in order to do this. Also, because it takes time, and you see the progress really on the slides here, you would start with the cluster new starting, and after 10 minutes, you see the provisioning will change to running. Then you basically, your really installation is ready. Then you can really use it. And then it's time to create the Jupyter notebooks. So, but this also means there's certain quotas, which is good for us so that we cannot use, let's say, infinite more. You have here the cluster overview. And if you want, maybe what we can just do is saying we want to delete one of those clusters because I just provided it to you. We maybe don't need it anymore. So let's look when we have this old cluster here, basically waiting. And here we can now say we want to actually terminate this one. And here's the there's some termination protection off. It's like double check, right? If you do really the termination, or if you want to do this, because in a way, if you have a very important job running on this or many different applications, you would destroy their base. Of course, in our case, this is not so important. It was just a test to get it running, a test to get the infrastructure to understand what it means to create this MapReduce and so on. And also this terminating will, of course, now basically takes time. And while we wait a little bit, we can go to some other slides. You see immediately that the kind of color will change here, and we'll look in a few other things here. That's almost all what I had essentially documented on the slide. There are some kind of showstoppers you see here. Essentially this, what I said earlier, this Jupyter Enterprise Gateway applications is really important if you want to connect Jupyter to this, so that you use PySpark as we have done with MS Azure in order to use Jupyter very quickly. Essentially out of this AWS environment, you need essentially to install this Jupyter Enterprise Gateway. In other words, if you forgot to put here a check mark on this Jupyter Gateway, you see that here, basically, which also falls back maybe to different EMR versions being available. You see some versions maybe don't have it available. Then basically Jupyter will fail. So early on in the configuration, you must set the base. And the same is, of course, true for Jupyter Hub. When you don't do this, then, of course, it's hard to connect to Jupyter. This is what we have demonstrated largely. So here, no big surprises right now. As I said, this might take even 10 minutes. And we will now wait a bit to have it essentially terminated and then basically come to the next steps. In order to save the time, because we have here very limited time to present all of this, we will go to one of the next steps, but come back to the cluster once this termination has been taken place, and we can reiterate on the new cluster that we want to create. Because then, with any luck, the quotas are better because we already have terminated one of the services. So coming to the idea now of using maybe some data, and admittedly in lecture 8 and 9 and 10, we will go this much more into the infrastructure as a services and so on, where we think about these storage services. But here it's a very easy to understand service. You would have set basically a virtualization layer that we had in one of our lectures already. Here you virtualize the storage. And we call that bucket storage because in a way, it's just, again, the simple mentality of put all data in a pot based on key value stores. In other words, this is not really an SQL, a structured way of doing it. You will see there's some metadata and access control, but it's a very easy way of just dropping data, right? Like MP3s, more or less, from Spotify, or streaming elements that we then use for our sound. This is a very nice scalable storage, which doesn't require really SQL updates and something like this. So it's really just with key values. You would say song or author could be potential keys, right? So kind of people, singers, songwriters, and so on. And it has also very nice interfaces from the implementation perspective. I told you that, for instance, Gradescope was using once also S3. So you always saw that they were using the REST interface to obtain our exams from the cloud and so on. So this was also another example where you just don't know how many students will be there. And basically you don't know everything in each of the different areas, but you just want to have a storage where you can drop some data. Also called object storage, and a very nice way of doing it. And of course, very scalable. Now, when you do this on Amazon, of course, you get the added value of saying very durable. So we talked about fault tolerance. So they do this, of course, in the world's largest global cloud and can guarantee your data is always 99.9 available, which is a very, very high number. Basically saying it will be never lost, the data, right? And of course, by swiping the credit card for it, you also want to have this, right? To pay for it, to have this good service availability. And then you have the scalability, right? Inherently. So again, you just pay for what you use, really. You don't pay many different gigabytes when you don't use that. And again, easy integration and migration from different, let's say, interfaces, and now to extract and also upload data. And this is what you could do also with AWS. You basically go now to the S3 interface. While we wait here and see that terminating the user request is still ongoing, we can now go to the S3 area, which is, of course, yet another service in the cloud, the Scalable Storage Cloud service. And when we go there, we will see basically then the opportunity to create so-called bucket stores, which are then essentially the things which are already installed here and there alongside different, let's say, alongside different servers that we have. But also, you see, I already tested the word count results here at some point in time last year, where that really still was working everything. And from there, we could also saw the word count results. Now, here you can create now a bucket. And on the slides, you see a little bit how we could call them, basically word count results. Similar, we would maybe use something like our servers names, BD 2001, and I think we called it something like S3 word count results, S3 word count results. So in the way we want to know now when we do some text and actually processing with MapReduce, all of this, we want to know where the results are stored. And this is what we actually do. And also thinking about the region is important, so that it should run in the same region where we have basically also the cluster, which is of course very important to consider that sometimes the different regions are a bit isolated. This is also true with keys, so it's a bit careful if you switch, let's say, easily always around these ones. My suggestion, if you're a starter, is always using in the moment the kind of default settings and later switching then to get the understanding. So you choose a bucket here that we can do there, and connect it maybe with one of those. Which could be another area. What you can do to connect those buckets, or basically you just don't connect it to any other, or create just a bucket plain. There are different security mechanisms, advanced settings, and so on, but a little bit we talk about this in the infrastructure as a service, but on the end, it's just too much to do all in university courses. You don't need to be experts in S3. They're really self-explained. You see also here that this bucket apparently was created. So now we have one of those buckets that you see here nicely on the lecture here, and this created an S3 bucket for us to put the word count results in. And of course, there are different services. You see the Glacier as an archive storage. So there you put maybe more terabytes in. It's much more cheaper to put it in the Glacier, as the name suggests, but also to basically get the data out takes much longer. It's in ice, so to speak. That's why the Glacier analogy. So here we talk about more tapes and other long-term storage formats. But if there's a very old MP3 collection you want to preserve forever that you maybe not daily use, then you basically can consider it as an S3 Glacier or old family photos of sorts. They are not gone, of course, they're in ice and can be always retrieved, but the retrievement takes time. Right, and then basically we observe a little bit what the cloud is doing. You see already it's getting a bit more interesting because now we have different services. We have an EMI service that we just terminated and want to know what's the status on this. Here we see, okay, it's apparently gone, and that is a good sign. Which other words means we have probably again quota, because when we go here, we have seen everything was nice and shiny with this until we encountered this problem that the request instances failed because we didn't have enough service quota for that type. The service quota can be configured by ourselves, by someone in your company that may be responsible for that. But this is something, of course, where now is nothing happening. So we have to reinstantiate essentially this and clone it, and basically do essentially the same steps that we have to do to clone it and bootstrapping it. And essentially you see here now it has cloned it in terms of all the software configuration. As I said, Jupyter Hub was important, Jupyter Enterprise is important, and some others we maybe here want to use. So essentially all what we just had, all the configurations we did, with one click, you can create yet another server instance. When we have the hardware the same way, it would be all, let's say, configured the same way, which of course is nice for our mechanism in a way. And now we say it's basically Spark cluster new 5 or so. And we take again our key pair, of course, and then we'll deploy again. And of course, this will now take again 10 minutes time that we don't really have to all doing this. That's why on the slides I show you how then essentially this is done. You can now put some form of an input data set essentially inside the environment to use. Basically with WordCount, you can use anything you want. Of course, it should be text for counting words. Here's an example of the CIA World Factbook, for instance, which is one of the books that will be analyzed in terms of word count and what's coming out of this. We talked already in some of the lectures, maybe a big library collection, which then wants to know how many books are there on politics, how many books are on sports. That's really easy recognizable by just counting the words and the occurrence of words. So things like that could be, of course, in a digital manner, easily feed it to this idea. And then you see here is interesting enough for us that there is already a pre-installed word count application here as part of the Elastic MapReduce if you just do this prefix. And with this, we can really quickly, start essentially this kind of word count with some storage area. And this is encoded in the steps which are optional when you do the cluster configuration. Right. So, of course, one way would be now that I can show you that we can create a Jupyter notebook. So let's do that with one of the clusters I already have here created before that just would reiterate on the situation that we had before. Let's pick this one. Here we said essentially this is running, and we could now go on and do the same MS Azure exercise with logistic regression essentially here. We just have to create a new notebook for it, and then would have, ccbd EMR notebook very new, and do some installations, but it doesn't matter. And we would, of course, we should pick this cluster that we actually have. Of course, here we don't want to have the starting new 5. You would have the other one that is already started connected to this. And then we basically see that also here we have to wait a little bit for basically starting up the cluster in terms of the kind of idea how to get to the notebooks. And then essentially you would just have the notebook as I provided one of the areas, and you would have the usual environment that we have also had in the HD Insight. Let me just come to this. Essentially here you have to choose a cluster that we just did. By doing so, wait a bit, you can create a notebook, pick a cluster, and then would have the similar Jupyter environment. You can pick a kernel with Spark, for instance, and then run essentially the same exercise we did in MS Azure. But here, the word count would be interesting, and just for the sake of the lecture to continue a little bit, we were doing this by doing a streaming program here, which is an example to show you for advanced options in the Hadoop space that we can actually add in order to do an aggregate maybe of all the different words, and where already these elements are pre-configured as an application for word count because it's such a popular application inside the cloud. But you have to do this here as the steps which are optional to really switch to this. And this was actually part of your assignment previously in one of the last year's episode. So here we don't do this. That's why we also don't need to put a big emphasis on it. But what it does was essentially streaming now the input data that we have defined with the CIA World Factbook. And then you get different parts of the data out. That is very normal in the Hadoop environment, that you get different parts out here to really build and aggregate. And if you go inside these, basically you see then all the different results. Also here you can have, let's say, failed MapReduce jobs, a good debugging environment. You see output director already exists. That could be problems. So here you change the directory name and then it works. And this would be the result looking in one of the parts. And of course, now you would write a program that combines the results of all these distributed parts that you have here to have the whole world factbook actually indexed in the sense of occurrence of the world. And here we see Iceland is actually appearing 964 times. So it seems to be an interesting country. inside this world factbook. You terminate the resources afterwards in WordCount. That's important.
This video uses a basic example.
I think you have now understand hopefully a bit better of MapReduce, how it works in the cloud. But of course, the assignment would have maybe strengthened the idea of key value pairs a bit more. But this is something where we basically then refer to the literature. Underneath was a lot of things of managing in terms of, the scheduling happening, what we didn't do. As you see, we just specified worker nodes and masters, and all is done automatically in the cloud. And also here we picked the different versions here. We picked HBase, for instance, or Hue and others. And you see that, of course, the Google Cloud and HD Insight have the same way these public services available, also sometimes nicely connected to Jupyter notebooks. Right, so that's all for the practical lecture today. We could carry on and wait for the cloud services to appear, for Jupyter Lab to appear. You see here, Jupyter Lab has been started up, and now you have your different kernels to choose from. When you start up, you have here different versions of PySpark. Maybe you have Python 3 and so forth, where you can work with in the same fashion we did this already essentially with the others in MS Azure. Good, but that's, I think, all for today. The time is over, and we basically have the third course hour, remember, for our quiz debrief and also for some additional question for assignment 1. So please stay online. Thank you very much for the lecture today. So next lecture will be next week on deep learning.